So we're going to add to our practice of polynomial vocabulary on this problem. First thing we're going to do is notice it says that this represents a blank polynomial. The blank here is classifying by degree, and so we need to have our list of what the degree names are. 0, 1, 2, 3, 4, 5 are the options, and so we've got constant, linear, quadratic, cubic, quartic, quintic, and then it's just n term, or not term, n degree. So we look at this one, and all we're looking for is the highest exponent. There is context for other degree outside of just the highest exponent. If you have a term, you've got to add the exponents to get degree. But for the ones we're playing with here in this class, we're going to focus exactly on the highest. So this is a degree 4. And so we just look here, and we'll find the name is quartic. So we just click the drop down, find quartic. They're not in order necessarily. There it is right there, quartic. And it has how many terms? This time we're not naming it. There isn't actually a name for 4 terms anyway. There are 4 terms here. We're just noticing that they're separated by addition or subtraction. So here is a term, is a term, is a term, and a term. So they're all separated by addition or subtraction. We have 4 terms. There's only names for the first 3, monomial, binomial, and trinomial. Anyway, the constant term. Now, the constant term is the term with a degree of 0. And so we got to look back here and see if we have a constant term. Why we care about the constant term is because the constant term is the y-intercept if it's present. If there's a constant term, that is the y-intercept. So we're going to go ahead and notice that there's a 5 in this problem that has no variable next to it. That means that is the constant term. This is 5. Now, the next one says, what's the leading term? The leading term is the whole term that has the highest exponent. Not to be confused with the leading coefficient. The leading coefficient is the number part of the leading term. So we have to figure out what the leading term is before we figure out what the leading coefficient is. So the highest exponent was the 4. So the whole term goes in this box. So we say 3x to the 4 is the leading term. And the number part of that is very simply the 3. Not the 4, the 3. The number in front of the variable, the number that's being multiplied by the variable. This is what I'm talking about when I say the leading coefficient. So leading coefficient is just the 3. And that is all our vocab that we're practicing for this problem. So I hope that you have this list written down, ready to go for subsequent problems for naming by degree. And then these definitions for leading term and leading coefficient. It's a big deal moving forward for polynomials. So let's continue our vocabulary practice on this problem. This time, we only have 2 terms. This is a polynomial of degree. Highest power here is 3. So this is, click this drop down here to find out that we have a cubic. That's what a degree 3 is called. It has 2 terms. We would call it a binomial, but we're not being asked for that name right now. The constant term is the one that doesn't have a variable next to it, and that is our 1/6. The leading term is this whole negative x to the 3rd. So we type in negative x to the 3rd here, and the reason why we care what the leading term is because its number part is the leading coefficient. The leading coefficient is the number part that's in front of the variable. So basically everything that's in front of the x to the 3rd What's there is a negative sign. You can't have a free floating negative. It's actually -1. So -1 is the leading coefficient for this problem, this polynomial. All right, we've got another great looking polynomial here. This one has 3 terms, so we would have called it a trinomial. Let's focus right here on this highest power. The degree is 5. So 5th degree is named quintic. So we click quintic. That's degree 5. It has 3 terms, each one here separated by the plus sign. So 3 separate terms. The constant term is the one that doesn't have a variable. That's this 1 right here. And so we say that that is our constant term. The leading term is the whole group with the highest power. That's 3x to the 5th. So we go ahead and write 3x to the 5th in there. And the leading coefficient is the number part of that, not the exponent, the number part in front of the variable that's being multiplied by the variable. So just the 3 is our leading coefficient. All right, on this problem, what we're going to notice is that we have a 1 plus x squared over 2. The over 2 part really throws a lot of my students. So first of all, the fact is there's 2 terms, and the highest exponent is the 2 up there. So this is a degree 2. So we name it here a quadratic. Quadratics have degree 2. Now there are also 2 terms, which isn't why it was called a quadratic, but there is a plus sign with 1 term, 2 terms. So second term, first term. There's 2 terms here. The constant term is this 1. So the 1 goes right here. It's the constant term. The leading term is this x squared over 2. So x squared over 2 is the leading term. Now, the leading coefficient really throws people off here because it's not written the way our eyes want to see it. But here's what you got to do to get that leading coefficient. You've got to look at the x squared over 2 as if it's really 1/2 times x squared. Because there's an invisible 1 in front of the x, this is really a 1/2 times x squared. When you multiply the x squared times the 1/2, you would multiply, it's really over a 1, so you'd multiply the x squared to the top and 2 times the 1, which goes back to giving us the x squared over 2. All that to say, the leading coefficient is this 1/2. So the 1/2 that's right here needs to come right out and be called the leading coefficient. So that's important analysis for our graphing capabilities later. All right, one more of that type for our final example here in this lesson. We've got 3 separate terms. The highest exponent is the 5. So that means that this is a quintic polynomial with 3 terms. So I say quintic with 3 terms. The constant term, the one that doesn't have a variable attached to it, is the -7. So -7 would be the y-intercept if I was to graph it. The leading term, the one that's connected to the highest degree, is x to the 5th over 7. And again, separating the leading coefficient from that means rethinking this to be 1/7 x to the 5th power. That is equal. Those are equivalent terms. And so the 1/7 is the number part that's multiplied by the x to the 5th. So the 1/7 is my leading coefficient.